how the assembly of capacitors, resistors and LEDs look on the breadboard. I kept all the smaller capacitors. There is 1 millifarad already discharged. Now I use the charged central capacitor, that is 4.7 millifarad. LED starts glowing successively, indicating the flow of the current in the circuit. How long this process takes place. I used a multimeter and connected across all the capacitors, and I observed that even after the LEDs stop glowing, there is still change in voltage in the circuit. The equilibrium is obtained in all the capacitors when the reading in each of them was about 1.4 volt. It did not become zero, although still there is a reduction, but the rate is so very slow. I wanted to know, to evaluate electric diffusion, I just took a segment of the circuit with only two capacitors, one charged, other discharged, with two resistors and one LED. In fact, to simulate addition of two dies at an interval, I wanted to study the effect of adding another capacitor of the same specification, that is 4.7 millifarad, after some time in parallel with the first one, and monitor the change in the voltage. Now I use the charge capacitor and connected by capacitor and monitor the change in the voltage using multimeter. Here are the results. Discharge from the central capacitor shows a decline curve whose linear and quadratic trends are estimated. Thus the slope dV by dt was found to be about minus 0.256 volt per second, assuming linear correlation, which is justified because r square is more than 0.8. When you plot the readings for change in voltage due to addition of second capacitor, we see a distinct change in slope, which showed marginal increase, which is as expected even in die system. Thus, it is possible to simulate chemical systems with electrical analogues with suitable capacitance signals and registers configuration.